Hello everybody and welcome to the 27th episode of Rust Game Development with me. I skipped a few weeks since I was last time live because I was a bit busy and also I had a horrible cold for a while the past weekend. But now we're back, so a bunch of stuff has happened and while I was offline, so I'm gonna show you what I worked on and then we can move on from there. So basically the biggest change I made was the Hierarchical Pathfinder. So let me show you. Actually, first of all, I changed my theme, so now I'm all like a brand new computer. I think it's a material UI that I modified a little bit. Alright, so these guys are chasing around. Disregard the bug where this person is losing their arms at a weird offset. But the other two guys survived. So basically I did right. So let me show you what's work in progress. This menu. So this is a workbench and you can select whatever you want to build and it shows you the ingredients and technically you can click here and craft it. So this is something that's work in progress now. And for example, if we build like a armor table, which is a crafting station for armor, you see first you'll build a workbench and then the table. So it already shows us a view in the thing. Sorry, it already shows us a view into what's happening here, but you can't build yet, you can't change priorities and so on, you can't use these buttons yet. And then if you click here, you have all sorts of items. So if you build a wood chest plate, it will appear here as a, it's called a wood shirt. I need to address this thing, but wood pants and so on. So this is work in progress. And let me adjust this a little bit. Okay. And this is what I last did here. But before we move on to continuing with the work on this task, I'm going to show you. I implemented hierarchical pathfinding, which is pretty neat considering that this work can be quite big for, well, for a star pathfinder. So actually, in order to show that better, I need to switch around some stuff. Okay. Okay, what's the function name? We need to do a few things. Add connection points, generate will do. Right, so as this builds, I'm gonna talk about that a bit, but first let me close the window because I'm freezing. All right. Where was I? Yeah, so high-level pathfinding, hierarchical pathfinding. So basically, the previous time we did pathfinding just on the game tiles, and that wasn't particularly great, especially if you have a path from one corner of the world to another, because you have to kind of visit a lot of intermediary points, and it gets even worse if you don't have a path, because you could potentially visit the entire world. And this gets a bit more complicated when you have also depth that's variable, so you can go up or down or whatever you want to do there. So that wasn't great. And there's this thing called HP, hierarchical near optimal hierarchical pathfinding, which is a paper. I'm gonna link it in the chat. Okay, this. The link. So this is it basically. I'm gonna explain to you a little bit how it works, but first we need to see it in action. And the main idea is that you generate a higher level graph of connections between rooms that enclose, dividing your map into bigger rooms, let's say, and then you just jump from the room edges. I need to draw. Give me a second. Okay. Good. Make a few room space here. Right, destroy my. So yeah. Basically, you have this game world. Whoa, I didn't do this in a long time, so bear with me. So this is your world with a lot of cells, like this. And you wanna go from, let's say, from here to destination here. Call this start. So you wanna go from this point to this point. So normally you'll just take this kind of an approach and reach it. But if these are super far away, so imagine there's another huge this, you visit a lot of cells, and if you don't find the path, you might end up visiting all the cells in your attempt to search for a path to the destination. So that gets super nasty. Things are just amazingly straight. But I didn't use this tablet. There's an optimization you can do, because you don't have to visit all the tiny cells to get to your destination here. You could find the path way easier, especially if there's like this, let's say it's a thing that can be traversed like a wall. This is another wall, right? So we could divide our world into a bigger set of squares. So let's divide it like this. N by n squares, right? So now we have our divided world. And from here, this doesn't give us anything. So we need to have connection between these big red boxes now. In order to know, because we know the end is in this red box, so this is 0, 0, 0, 1 on the big red boxes. This is, oh, this is 1, 0. This is 0, 1, 1, 1. So when you have the destination and the source, you already know that your destination is in 1, 1 and the source is in 0, 0. So now all you need to do is just find a path from this square to this big square. And the way you do that is we need some sort of a, let's put with green, some sort of a connection points between these big red rectangles. I didn't fully implement the paper, but the way they do it is, let's put more obstacles a little bit. So this is obstacle, another. So these are things that can be traversed. So they find all the nodes that have connection. So this node is at the edge, this node is at the edge, this node is at the edge. And they have a connection across these two squares. In a similar way, we have these nodes here. Whoa. Yeah, so as you can see, it's super fast. So I have like a bunch of them doing stuff. Not that fast anymore. I think I exaggerated, but anyway, it's way faster than before when we spent seconds for them to find the path to a location. Whereas now it's actually playable. And with an ungodly number of dwarfs. So that's pretty cool. Anyway, back to how this works. We add the connection points here. So these are connected. And the paper kind of transforms this into a door where they just remember this and this for a certain size. And they know that everything in between is connected. I didn't do that. For a cell, I remember all the connection points, which are these things at the edge. And then I know where they connect to and so on for all of them, not just for the two edges. And these are the outer connections, and then we proceed and generate the inner connections, which is from here. We can go here. From here we can go here. Well, let's say, yeah. So you get it. We need to have inner connections, and then from here to here we should have some other inner connections, right? And let's say, yeah, blocked. So this wouldn't have an inner connection to any of these. We would just connect to this one here. And the inner connection path can be even cached. So whenever I want to just traverse a cell, I just know exactly what nodes I need to go through, which is pretty handy. So then when you do the pathfinding step, let me generate the connection points here as well. They're connected, and all of these are connected with the ones above. So this data structure is basically just nodes with connection points, everything A star needs anyway, but it's at a higher level. And then we find if between 0, 0 and 1, 1 we have a path, and of course we do. But there's a tiny catch. We don't know where to start from, because here we might have like a wall and we have to take it this way. So from the start point, I just first find all the potential nodes that are on the edge using a normal pathfinding through here. And these are added to the search front of A star, or whatever the name of that thing is. So all these nodes get added as a potential next node in that heap. And then what you need to do is to find from this node if I can reach this cell, and that is at this high level. I know they're connected here, and then let's say we start with this one, because this one has a path here, right? And it's the smallest cost. And from here, I know I can go to this guy, and from this guy, I can go to any of these guys as well. One of them is here, and from here, this high level guy. And from here, I just need to manually check inside the cell if it's, we have a space. So the low level pathfinding is with blue lines, high level with orange, and then we have another low level pathfinding here to see if these two are connected, right? Because in case we have like a wall around this place, they wouldn't be connected, so it doesn't matter I reached 1, 1 if I can't reach my actual destination. But this simplifies everything by a lot, because we have 2 steps for low level pathfinding. So this is on the small cells, and then everything else for traversing high level cells is on the high level pathfinder, which is whatever n, that are also cached. So if you want to save memory, you don't need to cache them, but I also cached the path from A to B along with the cost. And it's basically the same. 99% is just the same A star path, you just operate on a different graph. So this is basically it. Now, you saw some stuttering in the previous video. I don't have a super great computer, but that previously took literally seconds, whereas now you can, sometimes it goes above 7 milliseconds, or in the worst case for that map, that's 256 by 256. And there are more optimizations. So for example, the number of tiny nodes, so these green connection nodes, can be, I can transform them into doors like the original paper does. Another thing I do is that things get complicated in my game because you can dig. So I also generate in the middle of the square connection points which are down to the level below. And that's it. That's basically, so let's say here I have some stairs that go to the level below. I know that 1, 0 is connected to 1, -1. This connection point here, because it goes down, this connection. So if I have a point at x, y, and -1, those would be actually taken into consideration. And as well, they work exactly like edge nodes. So I create links between everything that's connected in a square, and I cache them. So you see, this is actually one source of complexity, because all the edge places, they're not transformed like in the original paper. All of this would be a door, and it would have the yellow start and the yellow end, and we would know that everything in between is fine to cross. So then you just test a path through one of these, maybe. Or just go through the middle, it doesn't really matter. But I didn't do that, so I just go in and consider each connection in turn. So if I try this one, I'll try this one, and sometimes that's not super useful, so it hurts performance, because these all of them might be enclosed in a thing, right? With some wall here, because that's how the map is the big wall. The nice thing about this approach, though, so the high-level pathfinding thing, is that I don't need to do anything special. It's just generated from the original cell map data. We split it into n by n bigger red squares, so these things, and then in a pre-processing step we find the green connection points. So I have that high-level graph. Then if you dig around the map and you change the topology, I regenerate the connection points for that area, but not for the full map, because it's actually quite an expensive process, because I need to take a path from here to all of these neighbors, from here to all of these neighbors, just to find the internal paths and cache them. But if you just do, so if I dig here down, I'll just recreate the connection points here, plus checking that all these paths are correct still, and I didn't somehow break one of them. I didn't add the checking that it's correct, I just regenerate all the paths, but that could be further optimized. So this mess here is basically the high-level pathfinding that I did, and it works pretty well. I'm super happy with the result. If you have questions, I'm happy to, or you joined a bit later, I'm sorry, because now you just see this mess. But it's quite a good technique, especially for games like this where you don't have, so I don't have like a nav mesh or anything fancy. I just have a grid of squares. I do pathfinding on a grid of black squares here. And it was too slow, so you just split it into a higher level grid and do a pathfinding between those high level cells before going to the low level pathfinder, and which is with blue, to see if from an entrance on a cell you can get to your destination, or from the start, what are your options. Right, so this being said, let me put a little bit less. Okay. You've seen how they walk around, and it's super nice. I'm very happy with the result, and there's also more optimizations that I can do. So here in pathfinding, so you see it stayed like a few seconds. In those like 3 seconds it regenerates the high level pathfinding grid. But then it's fine. You can like plant something here in the corner. They don't care. Well, it's only 2 of them now, so it doesn't really matter, but okay. So this is the high-level pathfinding thing I wanted to show you. I have here like the code. So there's basically the same as a star, except I'm switching between high-level paths or low-level paths. And the low-level paths happen on the map cells, which are the tiny squares, and high-level paths happen on the bigger squares. And that's it. And I switch between them. So here at the beginning, I get the path to the starting point candidates, and I add them to a frontier fold. And then after this is done, you just enter the normal while you have a candidate from the frontier. If you're not at the end position, whatever. And you switch back to the low level pathfinder only if it's forced or you're in the same cell as the goal. Because we don't have any data there, so you need to do that. Which is quite simple, actually. Really nice idea. So you can even dig, no problem. So when you dig, you see it regenerates, but it just does it on this thing, this cell here, and almost 0 time to regenerate part of the map. Oh yeah, I updated IMGUI and build a bed. Okay, so now he is crafting the bed and the bed frame. Obviously these are not in order, so they will have to be eventually. Actually, I do believe though they might be in order. Let's build a bench. They're not in order. I don't know what this order is, but so for today we're gonna do some UI programming. So I use IMGUI here, which is pretty good. I like it. Quite simple. I spent about like a few days thinking on building my UI system from scratch and just gave up. It was a pain. So right, I want to change something from a drop down called combo. I think we can put text directly here. Oh, we can even color it. Okay. text would be this. I think this is it. It should work now. Okay, that's cool. So we have the ingredients, so this pretty neat. Now this guy is crafting the table for the loom, and then we will build a t-shirt. We need some. So yeah. And then we'll get dressed. Perfect. Well, this isn't good. Oh, he got hungry as he was carrying the t-shirt and he dropped it behind the tree. Never mind. All is good. I thought the t-shirt disappeared, but he just gave up transporting it, and then he went, ate something, and then went back. Also did some work on their need system. So if I put a bed here, not sure if we did this last time or if I showed you, they will eventually go to sleep. But now they have quite a lot of energy, so I won't wait for that. Alright, what else happened? This is about it. Oh, I raised the PR for IMGUI because it's just a small change, but initially this would be a reference to a slice of string references, which is kind of impossible to create from stuff that you read from a file, so from things which aren't hard-coded. So you could actually put them one by one in a list, but it's not ideal. And this is actually annoying me because I can't figure out a way to remove the task this task list thing. So you'll see it in a while. Like this. What the hell is this? Why do I see it? I don't know. So yeah, the way I got away with it is like in place here. But come on, there has to be a better way. What's it called? Maybe there's an option to hide label. What is this? Is this just I need to put 2 hashtags and this is it? Let's see. All right, that seems incredibly easy. So don't need to do this though. This is column number 1. What? Oh, and I got this really nice keyboard finally. I ordered it ages ago. That's not the... This is the number of the elements, but the... You need to push the width because it's like a state machine, so... This is good. We are creating some UI here. And I was thinking when you press craft, those items should go in a mini storage near the crafting station. Guys are kicking what's in there. Right, so this is pretty neat. Okay, all seems well and good. Oh, I did another thing. Forgot to mention it. I updated IMGUI, which was a pretty painless process for most part. Actually, I'm lying. No, it was a bit painful because I had to go from version to version because I couldn't figure out what was renamed. I had a really old version, so the way they do it is they deprecated certain fields and renamed certain things, like, I don't know, things around here. And because I skipped a lot of versions, I skipped the deprecation errors or warnings, because in the warning they tell you, by the way, don't use this, use this other thing. So I had to go one by one. But other than that, well, that's kind of my fault for sitting on a super old version, but other than that, it went quite alright. Camera dropping down. Okay. There's another nice thing about this game UI, which is right now, if let's take a look. It's automatically populated from the game UI. So for example, if we build a cooking table here, it will list all the items from that have a workbench, required workbench cooking table. So it's just baguettes. But for example, without changing any code, we will do a dwarven cake. And this is made out of 3 baguettes, and let's put some berries. Three pieces of bread, 1 strawberry gets you a dwarven cake. Good. Good. Okay, so this is done at the cooking table, right? And we run the game again, and we only changed some data. Oh crap. Texture map could not be loaded. Ah. Somehow Rust is completely silly and recompiles it. It's a bit annoying, but whatever. So anyway, we just changed some data, and now we build our cooking table here after these guys chop their heads out. They fight here because some of them are enemies. Oh, but well, you see, we have the baguette made out of grains, and the dwarven cake made out of 3 baguettes and 2 strawberries, which is exactly what dwarves eat. So that's pretty neat. Now if we press craft here, item, I think this is how MGUI deals with these things. What should happen? So what happens usually is we create a we had a recipe, and we create a task, and then we create this. what this does actually. Oh, it creates a whatever. So if we press the craft item button,